Okay, find the slope of the tangent line to the graph of the function f of x equals x squared minus 7 when x is equal to 2. Before we start the problem, let's go ahead and graph this. It's not necessary to graph this for the problem, but just to give us an understanding of what's going on. Let's draw a quick graph here. So we have x squared minus 7, so that's the graph of x squared, which is a parabola, shifted down 7 units. So our graph looks something like this. And we're looking for the slope of the tangent line when x is equal to 2. So we have a tangent line down here. When x is equal to 2, our tangent line looks something like this. And the equation of the line is y equals mx plus b. And we're looking for the m. We're looking for the slope of the tangent line. So that's visually what's going on in this problem. Now, earlier we discussed that the slope of the tangent line is given by the derivative. The derivative is the function that tells you the slope of any tangent line once you specify an x value. So another way of expressing this problem, find the slope of the tangent line to this function when x is equal to 2. Another way of saying this is find f prime of 2. Okay, so that's what the question is asking us to do. Find f prime of 2. Find the derivative and plug in 2. That will give us the slope of the tangent line to the graph of the function when x is equal to 2. And we discussed earlier that our definition of the derivative is the limit as delta x goes to 0 of the slope of the secant line, or the limit as delta x goes to 0 of f of x plus delta x minus f of x all divided by delta x. Okay, so let's apply this definition to the function that we're working with, the x squared minus 7. So f prime of x, in this case, is the limit as delta x goes to 0 of f of x plus delta x, which means we're going to take the x in this function and replace it with an x plus delta x. And so this goes in here. Okay, so that's x plus delta x squared minus 7. Then we're going to subtract off the original function f of x, which is x squared minus 7, all divided by delta x. Now, we definitely can't use direct substitution because we can't plug in a 0 for delta x because we have the 0 on the bottom of the fraction. We can't have 0 in the denominator. So let's see if we can do some simplifying. So f prime of x is equal to the limit as delta x goes to 0. So let's multiply this out. X plus delta x times x plus delta x. So first times first, that's x squared. Outer times outer is an x times delta x. Inner times inner is another x times delta x. And last times last is delta x times itself, or delta x squared. So we have x squared plus 2 of these x times delta x's, 2x times delta x plus delta x squared. Okay, so this is a little side work here. Okay, so we have x squared plus 2x times delta x plus delta x squared, and then we have our minus 7. And then we're subtracting the original function, so minus the x squared and minus the minus 7. So we'll have a minus x squared, and 2 minuses make a plus, so we have a plus 7. All over delta x. Okay, we could do some canceling here. We have a positive x squared and a negative x squared. We have a negative 7 and a positive 7. Okay, so we're down to, let's say, f prime of x is equal to the limit as delta x approaches 0. And we're left with a 2x times delta x plus our delta x squared all over delta x. A lot of delta x's here. Every term has a delta x. So let's go ahead and factor out the delta x that's common to both terms in the numerator. We could say f prime of x is equal to the limit as delta x goes to 0 of, let's say, delta x times, okay, from this first term we're left with a 2x, and the second term we have one delta x remaining, and there's a delta x on the bottom. Okay, now finally we could cancel off that delta x in the denominator. So it looks like we're at f prime of x is equal to the limit as delta x goes to 0, okay, of 2x plus delta x. Now, notice, we have not done any calculus yet. This is all algebra. We're finally at a step where we can do some calculus, where we could actually apply the limit. Delta x goes to 0. Can't separate this here. So this is equal to 2x plus 0 or just 2x. So the derivative, so what we've just found is if our function f of x is x squared minus 7, then our derivative f prime of x is equal to 2x. So this derivative function tells us the slope of any tangent line for any x value. In this case, we want the slope of the tangent line exactly when x is equal to 2. So to answer the question, f prime of 2 is equal to 2x, which is 2 times 2, which is equal to 4. So the slope of this tangent line, it's not exactly drawn super accurately because it looks like a slope of 1, but the slope of the tangent line when x is equal to 2 is 4, and that's what the derivative gives us.